Okay, today I'll just go through the counting principle, um, which most students struggle with. Counting principle is part of probability. We know this chapter counts like 15 marks of your final exam, according to the CAPS curriculum. So with counting principle, um, there's always going to be three questions or four questions that they're going to ask you in the exam. It does not change. Like, trust me on this one. Um, it's literally those three questions that they can ask, or those four questions, nothing else. Um, Suppose that you given the word math. Okay, from the word math, this word is made up of how many letters? Okay, we can count your grade one counting. It's one, two, three, four, five. So there are five letters from this word. Okay. The first question might be, in how many different ways can this word be arranged? Okay, basically they're looking for possible ways to arrange possible ways to arrange um the word. Okay, so the possible way to arrange this word, it's going to be okay. This is how I usually tackle this question. Suppose you've got these five letters, right? So I'm just going to draw five boxes, as you can see. Okay, on my first box, what I'm going to say is that how many different letters can stand in the place of this box? Obviously it's going to be five letters, because it could be your M, it could be your A, it could be your T, it could be your H, O, it could be your S. So there are five letters. Okay, on your second box, how many different letters can stand on this box? Obviously it's going to be four. Why is it four? Because one of the letters from this five letter word has been allocated on this first space, so I'll be left with four letters here. And then on this one, I'll be left with three, because the other two have been allocated in the previous two boxes. And then here I'll have two, and then on this side I'll have one. So you know that with probability, it's going to be the five different ways, going to be this one and this one and this one and this one and this one. Why am I emphasizing the word and? We know that the word and, it implies what? The intersection, which means it's the multiplication. Okay, and then you get 5 times 4 times 3 times 2 times 1, which is the same as what? 5 factorial. And your 5 factorial, you know from your calculator, it is 120. Okay, let's move to the second question. The second possible question might be, in how many different ways can this word be arranged if the letters T and S must always be together? um if they give you a restriction where they say the letters T and S must always be together, that means you'll have T, S, and then you've got these three other boxes. I told you that we could tackle this question using the boxes. And so if you've got letters T and S always together, and then you've got these three other boxes. Okay, what you could do, you just put a box between T and S, and then they'll form one item, which means you'll end up having a four-letter word. Bear in mind that the other box has got how many letters? Two letters. Okay, the first thing that might happen here is that T and S could arrange themselves into two different ways, which means where there is T, there could be how many letters? It could be two letters. And then on the place of S, it could be S O T. But the thing is, you have to bear in mind that the first um, value, or the first place, has been allocated to one letter, so it's going to be 2 times 1. And then the other thing that's going to happen, you just go and do exactly like you did in the first question, the different ways you could arrange this word. Now it has how many letters? Four letters, because on this space, on this box, how many letters could fit in this box? It could be four letters. And then, and what, when you move to the second box, how many could be allocated? It could be three, because the first one has been allocated the west to the one, to the previous one. And then it could be 4 times 3 times your 2 times your 1, which is um count as 2 times your 4 times 3, which is 12 times 2 is 24, and then you get your 48. Okay, I just hope this makes sense. Okay, and then I move to the third question, and then the third question might be, and in how many different ways could the word be arranged if the letters M and S should be in the ends? Okay, if the letters M and S should be in the ends, you know that in the middle you're going to have three letters. So the thing is, what could happen here on the place of M? What could happen is that S could come and sit here, or M could come and sit here, which means it's going to be two. Right, there are two ways in which M and S could be arranged on the first box, and then in the place of S, okay, between M and S, how many could be stay here? It could be one, because one of them has already been allocated in the first place, so it's going to be two. And then what happens here, these three are they going to shift three times, which is your 3 factorial. Okay, the other mistake that most people might make here is that they also want to shift M and S. No, you do not shift your M and your S. Why am I saying you cannot shift your M and your S? It's because they said they should be at the end. So you're done with your M and S. What you focus on is what is inside, which means it's only these three boxes that can move. Um, your 3 factorial as your 6, and then your 6 times 2, and then there are 12 different ways. So good people, that's it for counting principle. If you liked my explanation, or if you understood everything, you could just subscribe to my video. Thank you.